Okay, so today's lesson, our learning target is working with distributive property. And distributive property is used all over the algebra world. In a minute, I'll show you kind of where it leads us to, but right now it's almost like, why do we do it? Like we kind of question ourselves. Now, in years past, you have probably done associative property, commutative property, maybe property is zero. It's been a while, but those were some of the oldies, okay? The first thing I'm going to do is just kind of show you some odd stuff, or refresh your brain on some odd stuff. And it starts out with this. Okay. Now, we talked last week that if you have a number with a parenthesis up against another number, we knew that if it's up against that parenthesis, it means multiply, okay? So, honestly, 5 parenthesis 2 means 10, okay? Now, the next one is where the algebra starts coming in. If you have 3 with a parenthesis C, okay? We don't know what C is, but we can simplify this, as I'll call it, by getting rid of the parenthesis. And the simplest form would just be writing 3C. Okay, now I know it looks goofy, but later it'll work in distributive property. Okay, I know it's exactly the same. It is, our goal is going to be to get rid of some parentheses later. Okay, now if you had something like this, 3 times, or 3 with the parentheses, 6A. Okay. Now, once again, we don't know what A is. But, just like down here, we can get rid of the numbers. 3 times 6, 18. But, just like over here, we can't get rid of that A because we don't know what it is. And you can't get rid of it unless you know what it is. Or, it's an equation, which we'll talk about later. So, this is kind of just like a cheat sheet. I'm just trying to show you some stuff. Now, the first style of distributive property that we're going to do has these directions. So if you would, write these down. It'll say, use distributive property to rewrite, because that's all we're doing. We are just rewriting. We're not exactly solving. We're just going to rewrite it. To rewrite an algebraic expression. Okay. Now, algebraic expressions do not have equal signs. Okay, so I'll show you one in just a second. Okay. Move it up. Here we go. So, when they mean distributive property, they mean it's going to look like this. It's going to have a 5, or a number, I'm sorry, or a letter. It could have a letter. Parentheses and something inside. And the goal is to basically distribute out that 5. Now, I want you to think about, like, if we pass out papers, we're distributing those papers. Giving them out evenly, giving them to everybody, things like that. If we distribute this 5 to this y, what do we get?
7. It's because it's a plus sign.
But listen, we're not even there yet. I'm still here. 5 times y is
5y.
5y. Okay. Now, you do have a plus sign. Just copy the plus sign. And now we're on the last part. 5 times 2 is 10. Now, you have just done distributive property of that math problem. It's not, this part is very easy. Now, the goal is this. With distributive property, and this is why I couldn't explain the whole parenthesis first part, but you're right. Listen, we can't put the y and the 2 together because we don't know what y is. So in distributive property, what they do is they take the number on the outside and distribute it out so you can solve it. Now, this is a long shot. I'm just going to show you something. will you please not write this down? I just want to show you where it's leading us to, okay? If you had an equation, then this thing would be solvable. So what I mean by that is this. If there was an equals 20 on the end, then you would keep your equals 20 and you would distribute out the numbers just like you did. Now, I'm just showing you where your life is leading. Look up here, okay? You can solve this thing for y. My goal is down here to say y equals something. Okay. Now, the first thing you would do in the world of algebra would be get rid of that plus 10. Well, what's the opposite of a plus 10? Minus. So you would get rid of it doing this. You don't have to write this down, guys. Just watch. I'm just trying to show you something. What is 20 minus 10? 10. Okay. Now, you have a 5 times a y. What's the opposite of times? Divide. But what you do to one side, you got to do to the other. That's why I subtracted 10 on both sides. That leaves me with just a y. And 10 divided by 5 is 2. You just solved an equation. Now, this is why, listen, we're not doing this yet. I just wanted to show you that all this is where you're going in your future. You have to be able to do distributive property in order to get there. So we're starting out just distributing the numbers, which is the easy part, okay? So ignore all the red writing. Here we go. Let's do another one. Let's say we asked you to just distribute this. You have 3, 6 minus c. Now this time you have a minus problem. Doesn't change anything. Distribute it out. 3 times 6. 18. Copy whatever symbol. It's either going to be add or subtract. This one's subtract. 3 times c. 3c. You are done. You just did the distributive property. Yes, you should be writing all this down like I asked before I started this video. Here we go. Next one. Let's say we have 7a minus 2. Okay, just showing you that variables can be in different places. That's all I'm trying to do. So 7 times a, 7a. Bring down the minus.
14.
And then 14, yes. 7 times 2. Okay. Now, there's 2 other styles I've seen on today's little worksheet. One looks like this. And I want you to try to do the distributive property, and then we'll see if we get the right answer. Okay, here it is. And this. I'm just trying to show you every possible style of problem, I guess. Okay. No, that is the weird part. We're not even to the point of caring what the letters are. I know that sounds weird. We are just doing this. There is one other, we're going to do something different. We're going to kind of do the opposite of it in a minute. But because these are expressions and they have not said what the letter is, we can't do any more than this. Now, let me show you why, okay? If, and this is going to be a weird one, you ready? If there was a C right here, if it was 18C minus 3C, you could combine them. Because the C is the same on each one, okay? It would actually be 15C. 18 minus 3 is 15, and you'd keep the C. Now, if, and I'm just getting deep here, let's say there's a B here and a C there. You couldn't combine them because B would represent one number and C would represent a different number. You just leave it until someone either tells you B or C, to be honest, okay? That is why we're getting to this point and we're stuck. You would either need equals with a number or them to tell you what like C is or what A is. Okay? And it's kind of weird. Like, I don't know. It's weird that we don't solve them, but this is solving them, I guess, as far as you can go. So, okay, what'd you get for this one? 3 times 2?
6.
6 plus 18. A. Make sure you do 3 times 6 is 18. Keep the A. Okay, here we go. This one is written to me backwards. I don't see many of these, but why not? I just kind of do it this way. 3 times 8, 24. Bring down the plus, and then 3 times 3R, 9R. Perfect. Okay? Go ahead. Now, if you would, I'm going to draw a little squiggly line. Because I got to, just like here, you did 3 times both of them. So here I'm going to do 3 times both of them. Got it? Okay. Here is the other style. Okay, so this is one style of problem where you distribute it out. Now we're going to do what I call the opposite of it. You're going to have to find the GCF and kind of put it back together. Let's see. These directions will say this. Rewrite each expression by factoring out the GCF. Oops, there we go. The GCF. Okay. Keyword here is GCF. Greatest common factor. If you don't know that, I'm going to write it right here. But you don't have to if you know it. The key is greatest common factor. Okay. Now, okay. Basically, now they're going to give us a problem, an expression, and we're going to go in and put parentheses. Okay? Now, there is a little style to this because I have to see where you wrote out your multiplication tables. So, let's say you have this, 12R plus 4. And if you'll kind of watch the steps, I'll kind of show you which, this is the way I've been setting it up. I don't know that it's right or wrong, but, okay. I kind of skip a line, and right here I've been writing GCF. Okay. Now, there are 2 numbers we're working with. We're working with a 12 and a 4. So I'm going to write 12 with a little line and a 4 with a little line. And below here, I'm going to write what I call all my multiplication tables that equal those numbers. Hint, hint from me. Write them in order, such as the first one is 1. Start with 1 times 12. If you will do them in order, you will most likely not miss any. Okay, 2. 2 works, so 2 times 6. 3 works, 3 times 4. Now, if you put them in order, when you get to that number and the next number is like 4, if it's on that side, you should have already covered it. Like 5 wouldn't work, here's 6. 7 wouldn't work, 8 wouldn't work, 9 wouldn't work, 10 and 11 wouldn't work, and there's your 12. If you put them in order, it's not only organized, but it helps you to see the greatest one and not kind of miss it.
Do you have to put 4 times 3, or is it already there basically?
No, yeah, it's already there, so I wouldn't rewrite it. Good question. Okay, so 4 now. I'm going to do it. 1 times 4. And the only other one is 2 times 2. Okay. Now, what is the greatest, that's the key here, that they have in common? 4. Be careful. Don't pick 2. That's not the greatest. Okay, now, so 4 is going to be your number that is what I call going to go on the outside of your parentheses. Just like that. I just stick on the outside. Now, you've got to think division here. 4 will go into 12 how many times? Or 4 times what is 12? 3. Keep the R, don't drop the R. Bring the plus sign down. And how many 4s are in 4? 1. You just did what I call kind of backwards distributive property. Okay? It's not hard. It just like, if the more like you do it 4 or 5 times, it's like, oh, I get it now. Okay, so let's try another one. Let's say we have 21p minus 56.
Is that a line?
21p minus 56. Okay, yeah, 21p minus 56, and that's 21. Okay, list them in order. 1 times 21. Does 2 work? No. 3.
Yes.
3 times 7. 4. 5. 6. And there's my 7. So once I've reached 7, if I've done them in order, I'm good. Okay, 56. Here we go. 1 times 56. 2 times 28. Hey guys, I don't feel much pity at this point because you can use a calculator.
Okay.
So you get my drift. You could put 56 divided by 2 and get 28. Okay, 3. No, I had to think about that one. 4. Yes, 4 times is 36. 4 will go into 5 one time. 16's left, so 4 times what? 16.
14.
14. 4 times 4 is 16. Will 5 work? Nope. 6.
Yeah.
What's 6 times 9?
54.
54. It won't work. 6 won't work. 7.
7 times 8.
7 times 8. See how once you've reached it, like, once I've reached 7 and 8, that would be the next number.
Yeah.
So it's all in a nice, pretty order. Now, I start with 21. Is there a 21? No. 7.
Yes.
Yes, there you go. That is that GCF. Okay, so that's what you're going to use on the outside of the parentheses. 7 times what's 21? 3. Copy the P. Minus 7 times what's 56? 8. Now, you got it. Here's the weird part. Because of the directions using the GCF, if you were to go in here and like this one use a 2 or something, I would have to count it wrong. So make sure whatever you're using is the GCF. Okay, try these last 2 and then we'll kind of compare answers. And yes, you have to list the multiplication tables. What I call, you have to. And that's a 2. Guys, this is why I ask y'all before class starts to get calculators and things. Please get them before class starts. You can use them. You should know the tables that are involved in these problems. You should know the tables involved in these problems. Guys, list them. I'm not your answer key. List them. No, like I'm down here. Guys, start with 1. 1 times 8. 2 times 4. Does 3 work? Nope, there's 4. 32. 1 times 32. Listen, does 2 go into 32? Yes, because it's an even number. So 2 times 16. Does 3 work? No, because it'd be 33. Does 4 work?
Yes.
Yes. 4 times 8. Does 5 work? No. 6. 7. And then 8. Okay, so find that GCF. It is no. 8. Greatest. Be careful. Always start with that top number and looking back and forth. Okay, so if it's 8, I'm going to put an 8 on the outside. Now, the reason I'm doing this one is because it looks weird. How many 8s go into 8? 1. Okay. You can either write 1C or it is the same as just writing C, because 1 times any number is the other number. So like 1 times C is C. 1 times X is X. So you can write it either way. Now, 8 will go into 32 how many times? 4. You got it. Okay, let's do the second one. Many of you were staring at me on these multiplication tables. Guys, we should know these. 1 times 45. 2 won't work. 3 will. No, 3, no it won't. 4. Oh, 3 will. Wait a minute. 3 will. Sorry, 3 will. 3 goes into it once. 15 would be 5. There we go, 15. 4 won't, because that'd be 44. 5.
Yes.
Yes. 5 times 9. 6. No. 7.
Yes. No.
7 times 7 is 49. So you can't get close to that one. 8. Nope. Now I'm going to go do this one because I'm at 9 already. 1 times 27. 2 won't work because that's not even.
3 times 9.
3 times 9. Okay. 4. No, because it'd be like 24 or 28. 5 won't because it doesn't end in a 5. 6. Nah. 7. Nope. 8. Nope. 9. Got it. Okay. So, go in and find that GCF. 9. Okay. And I would factor it out. How many 9s are in 45? 5. 9 into 27? 3. Keep the K. Don't drop that K, guys. Okay. Basically, what we're going to do is, I'm going to give you your homework, classwork, and I'm going to do a few with you. Keep these notes out. It's not any harder. It's just the same stuff. Okay? The more you do, like the more you practice, the better off you'll be. Yes.
I was in your mouth. I was in your mouth. I was in your mouth.
Yes, you should
That
have
was in
20
there.
minutes ago.
You also.
Jack, I'll blow it up there. Okay. Here we go. So the top of this worksheet looks like the top of your notes. The bottom looks like the bottom of your notes, to be honest. I will show you how to kind of set up the list of GCF so they'll fit on here.
Please not.
Snotty.
I don't even have a snot.
The head is.
I need a pasta.
Sit down. Here we go. Now,
Is this classroom?
this is classwork / homework. Now, no, Those are notes, but you want to keep that out for just a second, probably. Okay, now, first, scratch this off. We were actually supposed to teach this last week, and basically it's Mondays. Okay. So here we go. Starting out. Distributive property to rewrite each algebraic expression. Now, make it real big so you can see it. Here we go. So, 6n plus 4, if we're going to write it out, it would be 6 times n, which is 6n, plus 6 times 4 is 24, and you're done. Like this is how easy this part is. 15 times 2 is 30. Bring down the plus sign. 15 times r. 15 r. You got it. Okay, number 3. Be careful with that S, that it stays looking like an S. 8 times S is 8S plus 40. You got it. Now, I'm going to leave this with you, but watch. If you would, please, right now, go down to number 16 with me, and I will help you through it. Okay, here we go. This is the part with the GCF. Okay, now I'm going to kind of show you how I set it up. You don't have to do it this way, but this was the way I did it. Okay, now, what I kind of did is this. I drew a line kind of up against those, and then I can fit it in the box. You don't have to, but this is just my thing. Now, over here, I did the GCF of the two numbers. So I did 5, and I'll do 20. And that way they're listed right here. You could do them to the left. It doesn't really matter. Okay. Now I'm going to factor it out. I'm going to write out all my multiplication tables. Which 5 is very easy. 20 isn't bad either, really. What, babe? Yes, there is only one for 5. Yes. Okay. Yep. So once you've got it written, find that GCF, which is 5, which is pretty easy because obviously if it's the only number other than 1. Okay. Now, let's factor it out. 5 with the parenthesis. So how many 5s are in 5? 1. X. Bring down the plus. And how many 5s are in 20? 4. There you go. And that's all you do. I have to kind of check this and that, but they go together. One times 5 is 5x.
Is that it?
That's it. No. No, because if you multiply now, 5 times 1x, you're going to get 5x. If you do 5 times 4, you're going to get 20. So it's already up there. Okay, let's do one more. Let's do 17. Just try to give you some examples. Okay, so we'll do GCF. 12 and 3. Yeah, think about what is your GCF?
3.
3. Okay, so think about it. Think about it as how many 3s are in that 12?
4.
Okay, 4. Keep the V. Keep the plus, because that's the kind of sign it is. How many 3s are in 3?
1.
1. Now, let me show you one other trick real quick to check your work. Look, think about this. Think about this. If you do what you would do at the top of the worksheet, if you do 3 times 4V, do you get 12V? 3 times 4v. Yes. If you do 3 times 1, do you get 3? Yes. So basically, if, when you were to kind of do these, you should get what's up there. If you don't, something's wrong. Okay? Keep going. I'm going to leave you with this to finish for homework or right now work. You've got a good bit of time, about 8 or 10 minutes. You may eat snack at the same time since you're my third period class. Thank you.